Okay, so question number 9 is to draw the Lewis structure for chloroform, CHCl₃. What are its electron pair and molecular geometries? What orbitals on carbon, hydrogen, and chlorine overlap to form bonds involving these elements? So we have chloroform, CHCl₃. So first we need to write its Lewis structure, so let's find the total valence electrons in this molecule. So carbon has 4, hydrogen has 1, and a chlorine atom has 7, and there are 3 of them. So we multiply 7 by 3, and we get a total of 26 valence electrons in the molecule. So now let's draw carbon as our central atom. We'll draw single bonds to all of the terminal atoms as well. And I'll show all of the lone pairs on chlorine. So now let's count out all the electrons I've drawn so far. So each bond contains 2 shared electrons, and we have 4 bonds, so that's 8. And then each chlorine has 6 valence electrons. So 6 times 3 is 24. I have a mind. Yeah, 6 times 3 is 18. So we have a total of 26 electrons in this structure. So the second part of the question is, what are its electron pair and molecular geometries? So if we look at this chloroform molecule, we'll see that our central atom, which is carbon, has 0 lone pairs, and it has 4 bonding pairs, or bonding groups. You can also call them charge clouds. So it only has 4 of these bonding pairs. So now let's look at a helpful VSEPR table and try to locate the structure of this molecule on the table. So when you have 0 lone pairs and 4 bonded atoms, this is a tetrahedral. So this is shown right here. So both the molecular shape and electron geometry is tetrahedral. And in terms of its hybridization, this is known as an sp3 hybridization. And the bond angles in between each atom is 109.5 degrees. So the next part of the question asks, what orbitals on carbon, hydrogen, and chlorine overlap to form bonds involving these elements? So if we look at the atoms that are given, then we have 3 hybrid orbitals overlap with singly occupied p orbitals of the chlorine atoms. And this forms a sigma bond. So sigma is this symbol right there, sigma bond. And we also have a last hybrid orbital with the hydrogen, so last hybrid orbital overlaps with a singly occupied 1s orbital. So this is the hydrogen bond to form another sigma bond. Okay, so let's see what the junior tutor said. Lewis structure for chloroform is shown below. So yep, this is correct. It has both tetrahedral molecular geometry and electron-pair geometry. Carbon and chlorine atoms are sp3 hybridized. One of 4 sp3 orbitals of carbon overlaps with the 1s orbital of hydrogen to form a sigma bond. The remaining sp3 orbitals of carbon overlap with the sp3 orbitals of chlorine to form 3 separate sigma bonds. The rest of the sp3 orbitals of the chlorine atoms contain the lone electron pairs. Yep, so this solution is correct.